Hello everyone, welcome to Machine Learning Laboratory, program number 6. Here the program number 6, the problem statement is assuming a set of documents that need to be classified, use the Naïve Bayesian Classifier model to perform this task. Here we can use the built-in Java classes or APIs to write the programs, and also we need to calculate the accuracy, precision and recall for your data set. Before getting into the actual program, let's have a background knowledge on what is text classification is. The text classification is the process of assigning tags or categories to the text according to its content. Here this text classification, which is used in many of the applications such as sentimental analysis, topic labeling, spam detections. So these are some of the applications of text classification. See, whatever the text or the data which we receive, which is in the form of unstructured data, so which is available everywhere nowadays, like in your social media, emails, chats, web pages, survey responses and many more. See, this text can be an extremely rich source of information, but extracting the insights from it, which can be a hard and time consuming due to because of its unstructured nature of data. Machine learning text classification, which can help businesses automatically structure and analyze their text quickly and cost effectively. So in order to automate the process and enhance the data driven decisions, we need a text classifications. Let's see how the text classifications works. See, this text classification can be done in two different ways. One is through manual and second one is automatic classification. See, this manual classification is a formal classification where a human annotator interprets the content of the text and categorizes it accordingly. See, this method, which may provide you the quality results, but it is time consuming and it is much expensive. Second one is an automatic classifications. See, this automatic classification, where some of the techniques like machine learning algorithms or natural language processing and other artificial intelligence guided techniques are used to automatically classify the text, which is faster and more cost effective, and it is accurate compared to the manual classification. So there are different approaches to automatic the text classification. One among that is your machine learning based system. So in the machine learning based system, instead of depending upon the manually crafted rules, machine learning text classification learns to make classification based upon the previously observed observations. See, by using your target labels, or what we call it as an instance or training data which has been labeled. So machine learning algorithms can learn the different association between the pieces of the text and a particular output. Output is nothing but your target value, which is expected for a particular input. Here an output is a predetermined classification or category that any given text could fall into. So let's see how the machine learning program works with respect to text classification. See, this machine learning text classification method is used to transform each text into numerical representation, which is in the form of a vector. See, one of the most frequently used approach is a bag of words, where a vector represents the frequency of words in a predefined dictionary of words. Then the machine learning algorithm is fed with the training data that consists of a pairs of featured sets and the tag. and the tags. So to produce the classification model, you can see this diagram here. So in the training process, what actually happens? The text are being taken. From the text, the features has extracted, and each features are converted, or the set of features are converted into a feature vector, and these feature vectors have been given to your model. So by using these features, your model has been trained. So what the next step is, once it is trained with enough training samples, the machine learning model can begin to make the predictions. So the same feature extracted here, the same feature extracted is used to transform the unseen text to feature set here, featured set, which can be fed into the classification model here, and which is in turns will predict the output or target values, or sometimes it is called as tags. So this text classification with machine learning is much more accurate than your human crafted rules system. So one of the machine learning text classification algorithms we have, such as Naïve Bayes family of algorithm, and second one is the support vector machine, which is called as SVM, and also deep learning and many more. So here first we shall see based upon the Naïve Bayes. We are concentrating on the Naïve Bayes. The Naïve Bayes family, which is of statistical algorithms, which are most used algorithm in a text classification and text analysis. One of the member for that family is multinomial Naïve Bayes classifier. So we shall see how this multinomial Naïve Bayes classifier are used to classify your text documents. So let's begin with the example, and we shall see with respect to the algorithms also. First, let's begin with an algorithm. Here the algorithm is split into two major steps. The first step is we have to train our model. Second step is we have to give our test samples to the model and ask the model to predict the output. So this is the first step. Here we shall see some of the notations and also the term which need to be evaluated. As I said that first we are going to give a set of examples or an instance to our model that has to be trained. So the instances which are taken are called as examples, and the corresponding output of or the corresponding target value of those instances are called as your V. Here you can see here, example is a set of text documents along with the target values, and next term is V, which is a set of all possible target values. So here this function learns the probability term. The term is probability of word, W is nothing but word, given value J, Vj. As I said that V nothing but your target value. So which describes the probability that a randomly drawn word from a document in class Vj will be an English word. It also learns the class prior probability, which is defined as P of Vj. The first step is collect all the words, punctuations and other tokens that which occurs in our example. So here for our easy understanding, we are concentrating only on the words which are appears in the text. So each and every word or every distinct word and other tokens which are occurred in the text document from the example will be considered as C, and that entire thing will be called as vocabulary. So here in vocabulary, what it consists of? It consists of all distinct words which are taken from the text document. So here the text document are nothing but your examples which are used to train your system or model. So this is our first step. So the second step is we need to calculate the required probability value of individual class and also the probability of word given class, so which is defined here. So for each and every target value Vj in V, we have to perform these steps. So kindly remember these notations properly, because we use the same notation to solve our examples also. So this entire steps will be done for a target value which belongs to capital B. Assume that if your capital B consists of two different target values, saying that there are two different target class, one is a positive and negative, so we have to perform this entire operations for 2 times with respect to positive target class and also with respect to the negative target class. So here what do you mean by docs.j? As I said that it is the subset of documents from an example for which the target value is Vj. So assume that you have a set of documents, that is training instances. So here these are instances. Assume that you have 4 instances. So out of 4 instances, the target value or the instance having the target values are plus, minus or plus and minus. And here these are all your text values or text words. So here every document which is having corresponding target value. What is this value consist of? Or docs.j says that docs or documents J with respect to positive, how many documents are there? Here if you see this, out of 4 there are 2 documents are there, that is documents of J or documents positive is equals to 2. Similarly for negative, you can see documents of negative is equals to 2. So the value you have received here. Let's consider we are concentrating only on positive probability or the documents which is having positive target value. So what is the probability of documents which is having the positive target? How do you identify the value here? Docs of J, that is documents which is having positive target, is 2 divided by total number of examples. Here instances is 4. So I have taken 4. So what is the probability here? 0.5. So this is how do we calculate this one. And next one is text J. Text J is nothing but a single document created by concatenating all members of documents which is having same target value. Here n is the total number of distinct words which is available in text J. Here we are not concentrating on the position, we are just concentrating on how many number of distinct words are there in your text. And the next one is we have to perform 2 things. One is we need to identify what is the value of n key and also what is the value of probability of word given the target value. So let's solve an example by taking these steps and you will understand clearly in detail. Let's see the second step here. The second step is we need to predict what could be the target value for our test data. So you are going to return the target value or estimated target value for an unknown document. So here AI denotes the word which is found within your document. And here you are going to return the value which is calculated based upon your Naïve Bayes. You are going to classify the text data based upon the value which you have received here. Assume that for a positive, or if your algorithm classify your test data as a positive with a value of 0.2, and for negative, if it is identified or if it returns the value as 0.26, then we say that your test data belongs to negative target value. This is how your text classification works. Now let's see the example and try to classify or try to predict the test data to which or predict the target value for your test data. Let's consider an example, that is a movie review. Here examples are nothing but your instances which is used to train your model. The total number of examples that what we have used is 5, and this is your text, and these are corresponding target value, or we can call it as a capital V, which is having two different value. One is positive and another is negative. There are 5 instances are there. As I already said that, what is vocabulary? Vocabulary which consists of a set of words, and those words are distinct words which are taken from these training instances or training examples. So when you identify how many distinct words are there from these examples, you can identify. So these are the distinct words, and totally there are 10 distinct words are there, or identical words are there. So this is our vocabulary. What is the value of the vocabulary is 10. Now convert your documents or the instances, which is in the form of text, into a featured sets, where the attributes are the possible words. You can see here, I love the movie, hated, a great, good, poor, acting. These are called as attributes, and the values are number of times a word occurred in the given documents. You can see here, for instance 1, or for document number 1, this word called as I has been repeated once, which is loud, which is found once, and also other words which are present only once in that particular instant. You can see in the third instance where the movie has been repeated twice in that instance or in that text document. So here we are converting your text files into an featured set, or a vector of features which consist of attributes and corresponding values. This is your second step. Now you are going to identify what is the value of doc J. So here what the doc J is, the subset of documents from an example from which the target value is Vj. Here Vj, what it consists of? It consists of two different values. One is positive and negative. Two different target values. Let's consider with respect to the positive documents. So document number 1, document number 3 and document number 5, which are a positive classes, and you separate these or pick those documents which is having positive class, put it as a separate. So where you can see here document 1, document 3 and document 5, and you convert this entire text into a feature vector where it consists of a set of words, distinct words, and also you will write the how many times a particular word is present in given document. So how do you identify the probability of Vj? That is probability of positive. How do you identify? That is documents. How many documents are there? There are 3 positive classes are there within 5 documents. So 3 divided by 5, which gives as 0.6 as a probability value for your positive. So next step is how you are going to create a single document where it consists of all the members of your documents. Doc J nothing but which consists of all the text words from the positive class documents. So here you can see from the 1, 2, 1, 3 and 5 are your positive documents. You try to identify, which is converted here in the form of text J. What the text J consists of? All the words from your documents which belongs to same class. So here n is how many are the total number of words in text J. So the total number of words which are available in a text J is 14. You can count here 1, 2, 3, 4, and if you count all these words, the total number of words which are appeared in your documents, with those documents are belongs to same class, and the value of n is 14. This is how you identify the value of n and also the words in your text J. The next step is for each and every word which are present in the vocabulary, we need to identify two different values. One is nk and another is what is the probability value of word given target value. So here we are considering only with respect to the positive target values or the documents which belongs to positive class. So out of 5 documents, we have considered only 3 documents, or the class or the documents which is having positive class are 3. I need to identify what is the probability value of each and every word which appears in this vocabulary. How do you calculate that? By using this formula. By using the formula. So I need to identify what is the probability of I given positive class. So how do you identify? What's the formula here? It is nk. What is the value of nk? Nk is nothing but number of times a word which occurs in the text J. So in this positive class documents, how many times I has present in this entire set of documents, in 3 documents? Only once. So the nk will be 1 plus 1 divided by n is nothing but what? The total number of words which are present in your entire text document which belongs to same class. So if you count all these words, the total number of value is 14. So 14 plus the value of vocabulary. What the vocabulary consists of? Distinct words. So there are 10 distinct words. So you calculate this word, compute this word, and you will receive this value. Similarly for A and also love. So you repeat the same thing for all the words which appears in the vocabulary. So here the value or here the word called as hated, which has not repeated not even once, and also the word called as poor. Still we need to calculate that. Yes. So this is the first step with respect to positive class documents. Similarly, we have to do the same steps with respect to documents which belongs to negative class. Now we need to identify what is the value of doc J with respect to negative class. Out of 5 documents, document number 2 and document number 4 which belongs to negative class. And also I need to identify the probability value of negative class. Here I have written positive. It is probability of minus is equals to 2 divided by 5. Why it is 2? Here 2 is nothing but the 2 documents which belongs to negative class out of 5 documents. So the value is 0.4. So this is how we calculate the probability of Vj with respect to negative. So now you create a text of J, that is text of negative, where it consists of all the words which belongs to the documents of negative class. Yeah. So there are two documents. You convert that entire text into the feature vectors, where it consists of the features and also corresponding value. The value here, the number of times a word which appears in that document. The n is here the total number of words which appears in the text J. Here how many words which appears in the text J? 6 words. 1, 2, 3, 4, 5 and 6. So n is equals to 6. So the next step is, for each of the word which are available in our vocabulary, we need to calculate nk and also probability of a word given negative class. So nk is nothing but number of times word k that occurs in a text J. J is here negative. Two documents are taken here. I need to calculate what is the probability value of I given negative class. One is nk. Nk is nothing but number of times the word wk occurs in text A. Here I has appeared only once, so 1 I have written here, plus 1 divided by 6. 6 is nothing but how many words which are available in your text J. How many words are available in text J? 6. So 6 here I have written, plus 10. 10 is the total number of distinct words which are available in your vocabulary. So this is the probability value of I given negative. Similarly, you find all the values or find all the probability value for all the words in a vocabulary given negative class, for a given negative class. When the new document has been given as a test document, I need to identify to which class this test document belongs to. So in order to do that, I need to identify the probability value of the words which are available in your test document. Here you can see there are 5 words are there in your test document. I need to identify the probability value of these individual words given classes. The classes here, target classes is one is positive and negative. And also we have identified the value of these individual words for a different classes, target classes. So take those values and substitute in the formula and you will receive the values. So what is the probability value of positive document? Here 0.6. And also what is the probability value of I given positive? It is 0.8. 0.0833. Similarly, you have the values with respect to positive class. And you substitute the values in the formula and you will receive the value is 6.03 in 10 to the power of minus 7. And similarly, we need to identify or calculate what is the probability value of these words given negative class. So substitute the values in this formula and you will receive the value as 1.22 into 10 to the power of minus 5. So compare these two values. Compare these two values. When you compare these two values, 1.22 into 10 to the power of minus 5 is greater than this value. So I can say that my new document belongs to negative class. This is how we classify or test data based upon your training data. So now let's see the program with respect to Naïve Bayesian classifier. Now let's begin with the program. Here we have a data set. The data set consists of a set of documents. The documents are nothing but a set of words, which is in the form of rows, and corresponding target value. The example that what we have taken, or the data set what we have taken, it consists of 18 documents and 2 columns. The first column is with respect to a collection of text, and second column is the target value of this document. And I label this column as message and this column as label. And I just load this entire data set, which is in the form of .csv file, into a data frame, and I label it as MSG. So in order to get the size of this data set or data frame, where it consists of this data, can be derived by using the method message.shape. And this label consists of in the form of text document, that is positive and negative. So for easy processing and easy understanding also, I convert this, or I map this positive as 1 and negative as 0. So in order to do that, I use this statement. Means I create another column called as label num, and I map positive as 1 and negative as 0. And as you know that, how do you divide your entire data set? As x and y. What is x? X is nothing but your features, and y is nothing but your target value. Here y is label num. We are not using this column, we are using this column, label num, where the label num consists of the value zeros and ones. 0 nothing but negative, and 1 is your positive, which has been mapped based upon the document values. So I print both x value and also y value. X is nothing but your text and corresponding output value. The next step is I want to split my entire data set into test data set and also training data set. How do you divide that? Based upon the split ratio. So here I divide my entire data set as into 2, as a trained and also test data. And here the features are divided, or your entire data set is divided into again features and also the target value. Features here is message and the target is label num. This is called as x train and this is called as x test, and this is called as y train and this is y test. This is how we split our entire data set into 4. Now I just print how many number of data which are taken as a training data, and also I just print what is the total number of test data by using the method ytest.shape and ytrain.shape. So next one is I need to output a word or tokens in the text documents. So as we have already seen that I have converted that entire text document into a featured set where it consists of a set of distinct words and also corresponding the target value. How do I do? Means by importing your count vectorizer. This count vectorizer which will convert this entire text into a matrix of tokens where it consists of words and corresponding the values which appears in the text. So I just by using that count vectorizer, I train my entire or the training data, whatever I have taken, I just convert that training data into vectorized form and I call that it as xtrain DTM. And similarly, I convert my entire test data into a vectorized form and I call that it as xtest DTM. So I just print how many words or tokens which are available in the text documents. And next step is I just print the feature names, or we can call it as how many distinct words which are there in my vocabulary. So to get that, I use this statement. So the next step is I just convert my entire training data in the form of arrays and the column name which is labeled as the feature names, and I store it as and I label it as DF. So the next step is we need to train our model. So to train our model, we use a multinomial Naïve Bayesian model. So to train, we use two parameters. One is your training data, which is converted in the form of vectorized, and also y train, x train, and also y train. And we are just going to identify, or we are going to predict what is the value for our test data. Here the test data you can see here again, which is converted in the form of vectorized, which is in the form of arrays, where it consists of distinct words and also the corresponding values. I need to calculate what is the accuracy of this model. So in order to do that, I just import the matrices from sklearn. The accuracy of the classifier can be taken by using this statement, where you are going to use for your test data and also what is the predicted value for your test data and corresponding confusion matrix, and you will get what is the precision and recall by using this statement. I have explained clearly in the previous video how do you calculate precisions and recall based upon the confusion matrix. So this is your entire program. Now let's see what is the output, sample output for this program. So in this sample output, I have already said that I have taken 18 text document. So the training data that I have considered is 13, and also test data is 5, and a token of words in the text document which consists of these are distinct words which can be called as a vocabulary, and the accuracy of the classifier is 0.6, and this is your confusion matrix, and this is your precision and recall value. So this completes your 6th program. You can visit the link which is provided in the description for more information about this program with respect to code and also the documents. Thank you so much.